Hi and welcome to Radicals Day 7. Today we are solving radical equations. In order to solve radical equations, we have a few steps that we need to take care of. One is to get the radical alone. After you get the radical alone, when I say radical alone, I mean you cannot add or be adding or subtracting anything to the radical. But if there's a number in front of the radical that's multiplying by the radical, that is still considered alone. Then 2 is to square both sides, 3 is to solve, and 4 is to check. So for number 1, the radical is not alone because I'm adding the 5 to the radical y. So in order to get alone, I need to subtract 5 from both sides. So I have radical y equals 3. Next step is to square both sides. So the square and the square root cancel each other out, so y equals 9. Then I just do a quick little check. 5 plus the square root of 9 equals 8. Well, 5 plus 3 equals 8. So 8 equals 8. And it checks. For number 2, by looking at that problem, is the radical alone? Yes, the radical is alone because I'm not adding or subtracting anything to the radical. So since it's alone, I square both sides. So on the left side, I get x squared. On the right side, I have to square the number out in front, so it becomes 4. And then the radical and the square cancel each other out, so I'm just left with 3 minus x, which was on the inside. Now I just need to distribute to solve. So I have x squared equals 12 minus 4x. Get it equal to 0, so I have x squared plus 4x minus 12 equals 0. Now I need to factor. I have x plus 6, x minus 2 equals 0. So I will get x equals negative 6 and x equals 2. Now I need to check. So I'll have negative 6 equals 2 times square root of 3 minus a negative 6, so 3 plus 6. So negative 6 equals 2 times the square root of 9. Negative 6 equals 2 times 3. So negative 6 equals 6. That is not true. So I have to reject that answer. And then the 2, it's 2 equals 2 times the square root of 3 minus 2. So I have 2 equals 2 times the square root of 3 minus 2 is 1. So 2 equals 2 times 1. So 2 equals 2. And that works. So my answer there is just x equals 2. For number 3, question we need to ask ourselves is the radical alone? Well, the radical is alone because I'm not adding or subtracting anything to the radical itself. Therefore, I need to square both sides. If I square the left side, the square and the square root cancel each other out, so I have x squared plus 13. On the right side, I can't do that because that square tells me to write it twice. So I have x plus 1. and I need to do double distribution or FOIL, so I get x squared plus x plus x plus 1. So x squared plus 13 on the left equals x squared plus 2x plus 1. Get it equal to 0. What's going to happen there is my x squareds end up canceling each other out. So we have 13 equals 2x plus 1. Subtract 1. So 12 equals 2x. Divide by 2. X equals 6. And a quick little check. So the square root of 6 squared is 36 plus 13 equals 6 plus 1. 36 plus 13 is 49. And we have 6 plus 1, which is 7. That was the square root of 49. Square root of 49 is 7. So that checks. So x equals 6 is okay. All right. I'm going to change the color here so you can see. For number 4, again, is the radical by itself. And in this case, yes, it is, because I'm not adding or subtracting anything there. Oh, I guess it didn't change the pen color. Oh, well. Square both sides. So on the left, you'll have 9x squared equals on the right, you'll have 4, and then parentheses, because the square and the square root will cancel each other out, 3x minus 1. Close parentheses, so I have 9x squared equals, distribute, 12x minus 4. Get it equal to 0. 9x squared minus 12x plus 4 equals 0. So then I need to factor this. When I factor it, we can do it by grouping. So factors of 36, because it's 9 times the 4. And we need to get a negative 12. So let's see here. Factors of 36 are 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. A pair that would give me a negative 12 when I added them. Would be what? Would be the 6 and the 6 would give us the 12. So break it down to 9x squared minus 6x, another minus 6x, plus 4 equals 0. Then we group. Here I'm going to take out a 3x, and I'm left with 3x minus 2. Here I'm going to take out a negative 2, so I'm left with a 3x minus 2. So we have 3x minus 2 times 3x minus 2. So if I were to set this equal to 0, I'd add 2, so I have 3x equals 2, and then divide by 3. So x equals 2/3. I'm going to get the same answer twice, because I have the same factors. And then I just need to check. So I have 3 times 2/3 equals 2 times parentheses, or radical, 3 times 2/3 minus 1. So here my 3's cancel out, so I'm just left with 2. Here my 3's cancel out, so I have 2 minus 1. So 2 equals 2 times the square root of 1, which is just 1. So 2 equals 2. So that does indeed check out. So that means our answer is then just the 2/3. All right, moving on. For number 5, in this case, the radicals are not alone. I need to get one radical on each side of the equal sign. I can never have 2 radicals on the same side of the equal sign and start solving. So I'm just going to add the radical y plus 25 to both sides. So I have 2 radical y plus 7 equals a radical y plus 25. Now that I have my radicals alone, I can square both sides. And I'm going to have to square the 2 in front, so I get a 4. And then parentheses y plus 7, because the radical and the square root cancel, or the square and the square root cancel each other out. On the other side, my square and square root cancel each other out, so I have y plus 25. So if I were to distribute my 4, I'd get 4y plus 28 equals y plus 25. I'm going to subtract y from both sides, and I'm going to subtract 28 from both sides. So then I'm left with 3y equals -3 divided by 3. Y equals -1. So then we just do a quick little check. And I have 2 times -1 plus 7. Let's try that again. 2 times times the square root of -1 plus 7 minus the square root of -1 plus 25 equals 0. So I have 2 radical 6 minus the square root of 24 equals 0. If I simplify 24, it's 4 times 6. So it's 2 radical 6 minus 2 radical 6 equals 0. So 0 equals 0. So that does check out. And the last one, my radical is not alone because I'm adding here. So I need to move the -2, so I'm just going to add 2 to both sides. So it's x plus 2 equals the square root of 3x plus 16. So the next thing I want to do is just square both sides. So I get x plus 2 equals square and the square root cancel each other out, so it's 3x plus 16. Let me backtrack here. Nothing cancels out there because it's not a square root. So I square it, so that means I have to write it twice. And when I write it twice, I'm going to have the FOIL on the left. So I get x squared plus 2x plus another 2x plus 4 equals 3x plus 16. So I have x squared plus 4x plus 4 equals 3x plus 16. So I need to get it equal to 0. So subtract 3x and subtract 16. So I have x squared plus x minus 12 equals 0. Factor x and x plus 4 minus 3. So x equals negative 4 and x equals 3. So we need to do our quick little checks. So I have negative 4 equals negative 2 plus the square root of 3 times negative 4 plus 16. So negative 4 equals negative 2 plus the square root of negative 12 plus 16. So negative 4 equals negative 2 plus the square root of 4. So negative 4 equals negative 2 plus 2. So negative 4 equals 0, and that is not true. So I'd have to reject that. And then I need to check the 3. So 3 equals negative 2 plus the square root of 3 times 3 plus 16. So 3 equals negative 2 plus the square root of 9 plus 16. 3 equals negative 2 plus the square root of 25. The square root of 25 is alright, so we have 3 equals negative 2 plus 5. 3 equals 3, so that one works. And the reason we have to do these checks is because when we're squaring both sides, we change the value of the equation. Therefore, we have to check for extraneous roots.